Okay, so for the next set of problems we're going to do, we're going to use the decibel equation. We're going to look at the decibel equation. So dB equals 10 logarithm of I over IO. And if I need to solve for I equals IO times 10 to the dB over 10 power. And the number for IO has a value as equal to 1 times 10 to the negative 12 watts per square meter. Now, intensity, if you look at the unit, it's watts per square meter. Watts is the unit of power, and so it is the power of sound spread out over a space. If I write it as dB, I refer to that as the intensity level. If I write it as I, that is the intensity. So in question 6, what is the intensity when we have an 85.0 dB sound? We're solving for I. And so we're going to just go to this equation. We don't have to show any algebra to get here because that's just a mathematical rearrangement. And if you haven't had that yet in math class, it'll show you how to get there. But so for now, just use it in this form. So what is the intensity in watts per square meter? So using that equation, I equals IO times 10 to the dB over 10. And so it equals 1 times 10 to the minus 12 watts per meter squared times 10 to the dB. Well, the dB is 85, so it's 85 over 10. So it's 1 times 10 to the negative 12 times 10 to the 8.5 power, and that will come out to be 3.16 times 10 to the negative 4 watts per meter square. Okay, we're going to skip 7. I'm going to leave that one to you to do. I will give you a little help. What is the sound intensity level? We're going to use the first equation produced by earphone screen intensity. That's I of 4 times 10 to the negative 2 watts per meter square. Let's go to number 8. It's a little bit more complex, not really harder. It's just a little bigger question. We have 10 cars in a circle producing 120 dB sound intensity level at the center of the circle. What is the average sound intensity level? That's the dB produced there by each stereo. So we have 10 cars producing 120 dB sound. The temptation would be to take the 120 divided by 10, but that doesn't work because it's logarithmic. What we have to do is find the I for each car. So we'll have our equation. The I overall is equal to IO times 10 to the dB total divided by 10. So the I of all of the cars combined is equal to 1 times 10 to the negative 12 watts per meter squared times 10 to the dB, which is 120 over 10. That comes out to be 12. So I have 1 times 10 to the negative 12 times 10 to the 12. That means the intensity of all 10 cars is 1 watt per meter squared. And so the I of one car is equal to 1/10 of the total I because there are 10 of them. And so it's equal to 0.1 watts per meter squared. And so we want to then find the dB of one car. All right, and so the dB of one car is 10 times the logarithm of I over IO. So the dB of one car is 10 log of 0.1 watts per meter squared divided by 1 times 10 to the negative 12 watts per meter squared. And if you do that math, and it's all on a calculator, so this is, you take 0.1 divided by 1 times 10 to the negative 12, hit the log button on the calculator and multiply the answer by 10, you come out to 110 dB. So one car is 110 dB, but 10 cars is 120. See, it's not linear, so you couldn't just divide that by 10 to get to that answer. Okay. And that's it for this. So you're just going to, there's just a few problems on that. So number 7, again, you're going to take and find the sound intensity of the dB level. You're going to use the dB equals 10 log I over IO equation, and you're going to plug in the value of I. Just some practice with that for you.